Hello everyone, myself Dr. Pradeep Kumar MR, working as Assistant Professor in the Department of Pharmaceutical Chemistry at KLE College of Pharmacy, Hubli. In this session, I will be discussing on the topic polynuclear hydrocarbons. In that, I will be detailing chemistry of naphthalene and its derivatives. Coming to the introduction. Polynuclear hydrocarbons are the fused or condensed aromatic hydrocarbons. They contain more than one ring and have two carbon atoms shared by two or more aromatic rings. Examples include naphthalene, anthracene, and phenanthrene. Here are the structures for the same, that is naphthalene, anthracene, and phenanthrene. Coming to the chemistry of naphthalene. Here is the structure along with the numbering for the naphthalene. This is the molecular orbital structure of naphthalene. All 10 carbon atoms in naphthalene are sp2 hybridized. The sp2 hybrid orbitals overlap with each other and with s orbitals of the 8 hydrogen atoms forming carbon-carbon and carbon-hydrogen sigma bonds. Since the sigma bonds result from the overlap of trigonal sp2 orbitals, all carbon and hydrogen atoms in naphthalene lie in one plane. So between carbon and carbon there is sp2 hybridization, and between carbon and hydrogen there is sp2 hybridization. Coming to the resonance structure of naphthalene. Based on the delocalization of electrons that is taking place in naphthalene, naphthalene can exist in these following three resonance forms. Coming to the different methods of synthesis of naphthalene at the industrial level. First one, from petroleum. Petroleum fractions, when passed over copper catalyst at 680 degrees centigrade, naphthalene and methyl naphthalenes are formed. Methyl naphthalenes are separated and converted into naphthalene by heating with hydrogen under pressure, which is also known as dealkylation. Second method is from 4-phenyl 1-butene. In this case, when 4-phenyl 1-butene is passed over red hot calcium oxide, naphthalene is obtained. Third method is from 4-phenyl 3-butanoic acid. This is the scheme for the synthesis of naphthalene from 4-phenyl 3-butanoic acid. When 4-phenyl 3-butanoic acid is heated with concentrated sulfuric acid, 1-naphthal is formed. This further on distillation with zinc dust gives naphthalene. Here comes the fourth method, that is Hayward synthesis, a very important method of synthesizing naphthalene. The synthesis of naphthalene by Hayward method of synthesis involves 5 steps. We will be seeing one by one. Step 1. In the first step, benzene and succinic anhydride are heated in the presence of aluminum chloride to form beta benzoyl propionic acid. This particular reaction is also known as Friedel-Crafts acylation. Coming to the second step. In the step 2, as it is shown in the reaction here, beta benzoyl propionic acid is treated with amalgamated zinc in the presence of hydrochloric acid to give gamma phenyl butyric acid. This particular reaction is also known as Clemenson's reduction. In the step 3, gamma phenyl butyric acid is heated with concentrated sulfuric acid or polyphosphoric acid to form alpha tetralone. This is a ring closure reaction. As we could see, in case of gamma phenyl butyric acid, the substitution chain is in open form. So here, due to the reaction with sulfuric acid or polyphosphoric acid, this particular open chain gets converted into a ring form, that is ring closure occurs. In the step 4, alpha tetralone is heated with amalgamated zinc and hydrochloric acid to give tetraline. Again, it is a Clemenson's reduction. In the last step, that is fifth step, tetraline is heated with palladium to yield naphthalene. Here it is an aromatization reaction. Coming to the reactions of naphthalene. In this, we will be seeing the electrophilic substitution reactions of naphthalene. Here we are showing you in the reaction what happens when the electrophile attacks the carbon number 1 and what happens if the electrophilic substitution occurs at carbon number 2. So here in the naphthalene, like benzene, it undergoes electrophilic substitution reactions. Substitution occurs primarily at C1, that is alpha position. The reason behind that is the two resonance forms which are involved in the intermediate carbonium ion due to the attack at the C1 and attack at the C2. When we see in the reaction, we can observe clearly that here when the attack at C1 takes place, the intermediate formed is more stable compared to the attack at C2, which is a less stable. As per the universal rule, always the stable molecules exist in the nature. Because of this reason, due to the occurrence of more stable intermediate atoms which can further lead to the stable compound formation. So here we are observing that the attack at C1 is quite common in the electrophilic substitution reaction, and this is the way how the electrophiles attack to the naphthalene at the C1 place and result in the stable compound formation. Coming to the different reactions under electrophilic substitution reaction. First one is nitration. Here, naphthalene undergoes nitration with concentrated nitric acid in the presence of sulfuric acid at 60 degrees centigrade to produce 1-nitronaphthalene. Coming to the mechanism, the way the reaction proceeds to understand. Here, the mechanism involves 3 steps. In the step 1, the electrophile nitronium ion is generated. In the second step, the electrophile attacks naphthalene at C1 to form the resonance stabilized carbonium ion. And in the third step, a hydrogen ion is eliminated to yield 1-nitronaphthalene. The mechanism helps us to understand the way the reaction occurring to produce 1-nitronaphthalene. Coming to the second reaction of the electrophilic substitution reaction, sulfonation. This is the reaction. Naphthalene undergoes sulfonation with concentrated sulfuric acid at 60 degrees centigrade to form 1-naphthalene sulfonic acid. If the same reaction is carried out at 165 degrees centigrade, then 2-naphthalene sulfonic acid is obtained. Third reaction is halogenation. Here is the reaction for the same. Naphthalene undergoes chlorination or bromination in boiling carbon tetrachloride, that is CCl4, to give 1-chloro-naphthalene. Fourth reaction, Friedel-Crafts acylation. Here the acyl group is substituted for the naphthalene. Here is the reaction. Naphthalene undergoes acylation with acetyl chloride and aluminium chloride in carbon disulfide to give 1-acetyl naphthalene. When nitrobenzene is used as a solvent in place of aluminum chloride, that is in carbon disulfide, it gives 2-acetyl naphthalene. Next one, Friedel-Crafts alkylation. Naphthalene undergoes alkylation with alkyl halides, that is methyl halides do not react. In the presence of aluminum chloride, it gives rise to 2-alkyl naphthalene. So here I am repeating, the naphthalene undergoes alkylation with alkyl halides, except the methyl halides, they do not undergo the reaction in the presence of aluminum chloride to give 2-alkyl naphthalene. Coming to the sixth reaction, chloromethylation. Naphthalene reacts with formaldehyde and hydrochloric acid in the presence of zinc chloride to form 1-chloromethyl naphthalene. Here are some additional reactions, that is reduction and oxidation type of the reactions. In that, first we will see the reduction reactions in case of naphthalene. So in the reduction reaction, we are having the normal chemical reduction reaction as well as catalytical reduction reaction. Coming to the first, the chemical reduction reaction. Naphthalene undergoes reduction more readily than benzene. With sodium and ethyl alcohol, it gives 1,4-dialene or 1,4-dihydronaphthalene. Whereas with sodium and isopentanol, it gives tetralene or 1,2,3,4 tetrahydronaphthalene. Coming to the catalytic reduction. Catalytic reduction completely hydrogenates both rings and produces decalene or decahydronaphthalene. Coming to the oxidation. This is the reaction for oxidation. Naphthalene is much more easily oxidized compared to benzene. By using chromium trioxide in acetic acid at room temperature, naphthalene undergoes oxidation to give 1,4-naphthaquinone. There is one more method. By treating the naphthalene with oxygen and vanadium pentoxide at 475 degrees centigrade, phthalic anhydride is obtained. Coming to the uses of naphthalene. First, it is used in the manufacture of phthalic anhydride, carbaryl for preparing the insecticides. Second use is especially 2-naphthal is used for preparing dyes and several medicinal compounds. Next is the study of derivatives of naphthalene. The compounds which are having the parent nucleus or the basic skeleton along with some substitution, the specific either group or the atom substitution are usually known as derivatives. Similarly here, there are compounds which are having some medicinal or industrial importance where they are carrying some additional substitution along with them basic parent moiety of naphthalene. So here we will be studying them. So here are the few examples. The first one is of 1-naphthal, which is also known as alpha-naphthal. Here is the second one, that is 2-naphthal, which is also known as beta-naphthal. The third one is 1-naphthylamine, which is also known as alpha-naphthylamine. And next is 2-naphthylamine, which is also known as beta-naphthylamine. Next are 1,4-naphthaquinone, also known as alpha-naphthaquinone. Next is 1,2-naphthaquinone, also known as beta-naphthaquinone. And the last derivative is 2,6-naphthaquinone, also known as amphi-naphthaquinone. Here we will see the synthesis of 1-naphthal or alpha-naphthal. So here 1-naphthal or alpha-naphthal can be synthesized using the starting material sodium 1-naphthalene sulfonate. When sodium 1-naphthalene sulfonate is fused with sodium hydroxide at 300 degrees centigrade, it gives sodium 1-naphthoxide. Treatment of this with dilute sulfuric acid yields 1-naphthal. Here is the same reaction. So one more method for synthesizing 1-naphthal is by using 1-naphthylamine. When 1-naphthylamine is heated with dilute sulfuric acid at 300 degrees centigrade under pressure, 1-naphthal is obtained. Now, the synthesis of 2-naphthal or beta-naphthal. Here, for the preparation of the 2-naphthal or beta-naphthal, the starting material used is sodium 2-naphthalene sulfonate. 2-naphthal is obtained by fusing sodium 2-naphthalene sulfonate with sodium hydroxide at 300 degree centigrade. Sodium 2-naphthoxide is formed in the initial step, which on further treatment with dilute sulfuric acid yields to naphthol. The next derivative is 1-naphthyl amine. Here is the synthesis of 1-naphthyl amine. By heating 1-naphthol with ammonia and zinc chloride at 260 degrees centigrade, 1-naphthyl amine is obtained. Two more compounds, that is 1,4-naphthaquinone and 1,2-naphthaquinone, are the few other derivatives. So first, synthesis of 1,4-naphthaquinone. Here 1,4-naphthaquinone is obtained by the oxidation of 4-amino 1-naphthol with potassium dichromate and sulfuric acid. Next is the synthesis of 1,2-naphthaquinone. Here is the reaction. 1,2-naphthaquinone is obtained by the oxidation of 1-amino 2-naphthol with ferric chloride or potassium dichromate and dilute sulfuric acid. Coming to the next derivative, that is 2,6-naphthaquinone. The synthesis involves 2,6-naphthaquinone is prepared by oxidizing 2,6-dihydroxy-naphthalene with activated lead dioxide in warm benzene. Thank you.